We'll definitely see this website in class, but it gives a nice interactive look at how covalent bonds work, so feel free to check it out on your own. We've spent some time recently drawing ionic bonds in which electrons are transferred from atoms of one element to those of another. Now we need to learn how to draw covalent bonds, which we've learned involve electrons being shared among atoms that don't want to transfer or give up their electrons. Covalent bonding has a bit more to it than ionic, but it's the same principles. We also have a little bit more freedom here of how we sort electrons in a molecule. This probably won't make a lot of sense until you actually see it in action, but let's take a look at the process before we do a few together. Step 1. We need to count how many valence electrons there are in all the atoms that are forming a molecule. So just add everything up. Remembering that the valence electrons are the glue that holds atoms together, this tells us what we have to work with to connect our pieces. Step 2. Next, we'll put our atoms down the page, connected by single bonds to start. This is to make sure all the pieces are there, accounted for, and a basic structure. Things to keep in mind here, though. If there's only one of an element, try putting in the middle of the molecule with other atoms attached around it, like the middle of a wheel with spokes coming out. And because a hydrogen atom can only form one bond, hydrogen atoms will only ever stick off the side of the main parts of the molecule and will never be a central atom that other things are arranged around. It just can't happen. Step 3. Count how many electrons of our total supply have already been used to form the initial single bonds that we've drawn. So if we know we had 10 electrons to start that we have available, and we used 4 of those things to draw our initial bonds, then we only have 6 left. Remember, if there are only 2 electrons in every line we draw. If there are any electrons that have not been drawn yet, draw them in any empty positions around the atoms, starting from the outside first and then moving towards the center of the molecule. Step 4. Now that we know all of our electrons are on the page somewhere, we check to see if every atom has the correct number, essentially seeing if our electrons are in the right places. Remember that most atoms want 8, with hydrogen wanting 2. An atom can claim ownership of any electrons that are positioned around that atom, like the simple Lewis structures we start out drawing to start the chapter. But an atom also now owns any electrons that are in a bond connected to the atom. So any lines that come off that atom can claim ownership of the electrons in that bond, in that line. So if an oxygen atom has 2 bonds connecting it to something else, all of the electrons in those 2 bonds can be considered to belong to that oxygen atom. Step 5. If the arrangement of electrons we have doesn't satisfy the desire of every atom to have the correct number of electrons, then we can just move the dots around a little to make it work. But we won't see that just yet, so we'll ignore it for now and get to it a little bit. Everybody ready? Make sure we've got a periodic table and something to write with. Let's do some drawing. First molecule up is H2, hydrogen, the smallest bonded molecule, so just 2 tiny little hydrogen atoms combined. Step 1 says count our valence electrons, so we'll fill in this chart here. For our element, I just have hydrogen. Each hydrogen has 1 valence electron, but because I have 2 atoms of hydrogen, I just multiply the 1 times 2, and that tells me I now have 2 total valence electrons. So that's what I have to work with. I have to use 2 electrons to combine and connect these 2 hydrogen atoms. Step 2 says to arrange the atoms on the page connected by single bonds. So I'm just going to draw both the H atoms and connect them with one line. That's all I have. It's just a very simple molecule to start out, so just I have an H here, and I have an H here, and just to make sure they're not kind of floating around the page randomly, I'm just going to draw one line to make sure those 2 things are connected and locked into place. For step 3, I count how many electrons were used to make that bond. Because each bond line represents 2 electrons, I know I've used 2 electrons already. So there's 1 and 2 electrons in this bond right there. So we used 2 electrons total. Because I only had 2 electrons to work with, I now know that I've used both of my electrons. So 2 minus 2, I have 0 electrons left. All my electrons are on the page, so I don't have to actually add anything more now. So it says here, draw the rest if needed. We don't have any more. This is exactly what it should look like. Step 4 says, check if everybody has the correct number of electrons. H on the left, remember H is small, it only wants up to 2 electrons. So H has 1 and 2 because it's in this bond right here. That bond is connected to the H on the left. It holds and accounts for 2 electrons. So this H over here has the 2 it wants. The same thing for the one on the right. It is also attached to that bond in the middle, so it can also claim ownership of those 2 electrons. So it's also happy. Step 5 says rearrange if we have to. We don't have to. Everybody's happy. There are no more electrons to be moved around anywhere. This is what H2 looks like, and we're done. The next example is F2, a diatomic molecule of 2 fluorine atoms. So very similar to H2, which is a different element. Adding up our valence electrons, we see that we have just one element, which is F. Each fluorine has 7 valence electrons because we have 2 atoms of fluorine. 7 times 2 is 14 electrons total. So that's what I have to work with. 14 valence electrons will be the glue that I have to attach and hold together these 2 fluorine atoms. Now we draw our atomic symbols and connect them with single bonds to start. So I'm just going to draw two F's on the page right here, and just put one line between them to show that they're attached, and again, not kind of floating around doing the weird things. Notice here that since we only have two atoms, there's really only one way to do this. I mean, I guess you could put one F on top of the other, but basically the same thing. But put them next to each other, that's really all you can do. The more atoms you have, the more possible ways there are for you to arrange them, but this is a very simple molecule, so it's just a very straightforward structure. Step 3, we use 2 electrons to make the initial bond between the fluorine atoms. So we still have 12 electrons that need to be assigned positions on this molecule. As we had the 14 to start, there are 2 electrons in this bond right here, so 14 minus 2, we know we still have 12 left. So I need to now arrange those 12 molecules around, and it says we start on the edges and move inward. Since there are only 2 atoms, each of them is technically on the edge of the molecule, so it really doesn't matter where we start. I'm going to erase those numbers here, just so I get it a little bit cleaned up, and let's do this. So starting on the left, I can draw 2 dots each on the top, left, and bottom of this fluorine. So there's room for 2 dots up here, there's room for 2 electrons over here, and there's room for 2 electrons down here. The right side of this fluorine on the left is already blocked because of this bond that's there, so I'll just move over to the other side. On the left, I've now used 1, 2, 3, 4, 5, 6 electrons of the 12 that I had left. So I need to go now, and I'll take 6 away from those 12. And I know that I still have 6 left that I have to place on the other fluorine. So I'm going to do the exact same thing. 1, 2, 3, 4, 5, 6. That should be all of my electrons that I had to start. Let's just count to make sure. I've got 1, 2, 3, 4, 5, 6. There's 2 in the bonds, that's 7 and 8, 9, 10, 11, 12, 13, 14. So all my electrons are there. Again, I'm just going to erase all these little blue check marks so I have it a little bit cleaner so I can look at this easily. But we know that now all 14 electrons we had to work with are actually on the page and accounted for. So all our electrons are there. Step 4 rather says check we have the correct number of electrons. We do. We now need to just check if everybody has a complete octet, see if everybody's happy. Most elements again want 8 valence electrons, so the fluorine on the left here has 1, 2, 3, 4, 5, 6 electrons around it, plus the 2 that are in the bond. That counts as 8 on the left, so he's happy. The fluorine on the right has 1, 2, 3, 4, 5, 6 electrons around him, and again he's also connected to the 2 electrons in the bond, so there are also 8 electrons that this fluorine can count ownership of. Each one of them has 8. All of our electrons are there. We don't need to rearrange things, so again we can cross off step 5, and that is what a diatomic molecule of F2 looks like. A few vocab words here. The electrons that make up a covalent bond, those 2 in each bond, are called simply bonding electrons. The name tells you exactly what's going on. Where are the bonding electrons in the Lewis structure we just drew for the F2 molecule? There they are. There are only 2 electrons involved in bonding in this molecule. We counted 14 total valence electrons though, so what are the other 12 electrons doing? Well, the other electrons are just kind of hanging out with one atom or the other. They're staying where they started since each fluorine had 7 valence electrons in the first place. These electrons that surround an atom without taking part in bonding are called lone pair electrons because, and I hope you're realizing these are not really sophisticated or tricky names, they're pairs of electrons, kind of by themselves, lone. Yeah, tough stuff, I know. Just to drive this point home again though, keep in mind that each fluorine starts with 7 electrons. So fluorine here, 1, 2, 3, 4, 5, 6, 7, and this fluorine over here, 1, 2, 3, 4, 5, 6, 7. These 2 by themselves in the middle now come together and form a bond. So right here, these 2 electrons will form your bond between the fluorines. The electron on the left attracts to the right fluorine's nucleus, and the electron on the right attracts to the left fluorine's nucleus. The number of electrons doesn't change, but because they're sharing them, now each atom can claim to be connected to 8, and both atoms are stable and happy. We just drew H2 and F2. Now I'll take one of each element and draw HF. All the same steps and rules apply. Pause the video, follow the steps on the left to try and come up with the structure of this molecule, then unpause to see how it should actually look. One more, and this is a little tease of the organic chemistry chapter we'll do to finish the year, because that's not much more than just drawing season H's all over the place. Same deal here. Pause, draw, check your work. I'm really only partly kidding here. We're going to draw a lot of these things. No quiz on this, tomorrow at least, because I want to be able to get a bunch of practice in. Now go finish your form.